Let's compare the instantaneous velocity and average velocity using the following example. A ball is dropped from a height of 64 feet. Its height above ground in feet t seconds later is given by s of t equals negative 16t squared plus 64. And if you take a look at this graph, of s with respect to t, is s of t is the height is dropping from 64 to the ground, 0. And it takes how many seconds? 0 to 2 seconds. So it takes 2 seconds. What is the instantaneous velocity? Whenever you're talking about the instantaneous velocity, you're really talking about s prime of t, okay? Instantaneous, at the instant, it means the limit as the change goes to 0. So the instantaneous velocity when the ball hits the ground is at 2 seconds. So we are really looking for what is s of 2. And for part B, what is the average velocity? And average velocity really means s of B subtract s of A divided by B minus A. And our interval AB is 0 to 2. So this is how we solve the problem. So first, what is the derivative of s? You take a look. It's 16t squared plus 64. So the derivative of negative 16 times t squared, right? So it's negative 16 times 2t plus derivative of 64, 0. So it's really negative 32t. And we want to know the instantaneous velocity when it hits the ground. So it's when t equals 2. So we plug in 2 for t. We get negative 64. And the unit for velocity is feet per second in this case. Now what about the average velocity? So we really need is the height at t equals 2. Subtract the height at t equals 0 divided by 2 minus 0. So on average of this 2 seconds, what is the average change in height, right? So it's 0 subtract what is s of 0. So the position or the height at time 0 is 64 divided by 2. So it is negative 32 feet per second. So they are two different concepts.